The D. In goal state, there are 3 blocks in the supporting structure of D, but here there are nothing, so don't do anything. And here consider this C. In goal state, there are 2 blocks under C. Here there is only 1 block, so 1 block is placed wrongly. Generally, if we compare this with goal state, the goal state must obviously should have 2 blocks under C, but there is only 1 block placed. That means this 1 block is placed wrongly. So if I placed wrongly, I will deduct. I write -1, right? If I placed correctly, I will add +1. If it is placed wrongly, I will subtract -1. In such a way, I have defined my heuristic function. Now consider A. In the goal state, under A there are no blocks, but here under A there is 1 block. That means that 1 block is placed wrongly, and we should not have any blocks under A, but it is placed wrongly, so -1 again. So we considered all the blocks, so it is -2. So for example, I am explaining you, right? So I have defined heuristic function in such a way that whenever I make a move to these blocks, I add value 1 if the supporting structure has correctly placed, and if the supporting structure is wrongly placed, I will subtract -1. I will consider the total of this value as my heuristic value. I will compare this heuristic value with the previous one. If it is better, then I will move this state. I take this state as my current state. So here I have explained you how the heuristic is calculated using 3 different states. Now we will go to the actual problem. So this heuristic function can be defined based on your logic, based on the problem, and based on the optimization criteria you choose. So the heuristic calculation is different, the path we follow is different, so it is not systematic, but we should get optimized result. So you can define your own heuristic function, but it should lead to optimized value, right? So now we will see how this blocks world problem is solved using my heuristic, which I defined. Like, if the supporting structure is correctly placed for each of the block, I will add +1. If the supporting structure is wrongly placed for each of the block, I will subtract -1, and I consider these values of all the blocks. I will sum up them and I consider that as my heuristic value, right? Now we will go to the solution of the problem, the entire problem. Yes. So this is my initial state, first state. H is heuristic value. In brackets I am writing in parenthesis I am writing the state number, right? Here my goal state, I am representing the goal state here, which is there in the previous slide. The goal state should be like A, B, C, D, and we'll also find out the heuristic value of the goal state, right? G. Heuristic value of the goal state is, so compare this with this, right? So under A there are no blocks, under B there should be block A, so it is correctly placed, so +1, and under C there should be 2 blocks, so in this state it is currently placed, so +2. Under D there should be 3 blocks, so it is currently placed, so +3. So my heuristic value is 6 for the goal state. Keep this in mind. So every time we make a move of the state, we should compare with this, right? The heuristic value of the goal state is +6. Now consider the first state. This is the first state. So Now I need to calculate heuristic value of this function also. So compare this with the goal state. So under B there are nothing, under C there is only one block, but in the goal state, this is the goal state, right? Under B there should be, under C there should be two blocks, right? So those are wrongly placed, right? So it is -1. Next, under D there should be three blocks C, B, A, but here under D there are only two blocks, so -2, two are placed wrongly. So under A there should be nothing, but here under A there are D, C, B, there are D, C, B. In the goal state under A there should not be nothing, right? So 3 are wrongly placed, so -3. That's how we get -6 here, right? So the heuristic value of this state is -6. So from this current state we will make one move. So what I am doing is, there is only one possibility from this state, that is A will be, I place A on the floor. This is my current state. I told you about two constraints. One block should be moved at a time, and it can be placed on the floor or the top of the other block. Those two are the constraints to follow while making movement in the blocks, right? So I placed A on the block. So from the present first state there is only one choice for us, no other choices. So simply I placed block A on the floor. Again I need to calculate heuristic. How we need to calculate? Should compare this state with the goal state, right? So under B there should be A, but here nothing is there, don't calculate anything, right? Under A there should be nothing, here also there is nothing, don't calculate anything. Under C there is only B, but in the goal state under C there are B, A, so there should be two blocks, but there is only one block here, so one block is wrongly placed, so it is -1. And now consider D. Under D in the supporting structure there are two blocks, but in the goal state under D in the supporting structure there are three blocks. So these two are wrongly placed, so I am subtracting -2. So I have considered all the blocks, so it is -3, right? So this is how we get -3. And from this state I need to move one block again. So again there are two choices to the third state. What are the two choices? Either you can move D on the block, not only two choices, three choices actually. You can place D on the floor, you can place D on the top of A, or you can place A back again to D. That may not be our choice, but there is a possibility. So three possibilities are there, but as it is a simple hill climbing, we can take any one of that, and we will consider only one movement at a time. What I am doing is, I am taking block D and I am placing on the floor, right? So this is my third state. So again we need to calculate the heuristic value. So to calculate the heuristic value, I need to compare this state with the goal state again. So under B there is nothing here, but in the goal state under B there is one block. So here there is nothing in this state, so don't do anything. Under A also there is nothing, don't do anything. Under D also there is nothing, no need to calculate. Under C there is only one block B. Here under C there are two blocks, so one block is placed wrongly, so I am subtracting -1. So I consider all the blocks, that's how I get -1 here. And so we need to take this state or not, we should check that. -1 is better than -3, so I am taking this state as my next state. So from this current state again I can make a move. So I can take C and place on the top of A, or I can take C on place on the top of D, or I can take C or place on the floor, right? Three alternates are there, and not only three, there are different. A can be placed a block, D can be placed on A, so there are more alternates from the state 3. Here what I am doing is, we consider only any one step, arbitrarily we take one step. So here I take C and place that on the floor. Here in the support structure of each and every block there are nothing, no blocks are there. So my